The summary of experimental features and observations. Now we will conclude here the experimental observations. First thing, for a given photosensitive material and frequency of incident radiation above the threshold frequency, the photoelectric current is directly proportional to the intensity of incident light. One conclusion. Second thing, for a given photosensitive material and frequency of incident radiation, saturation current is found to be proportional to the intensity of incident radiation, whereas the stopping potential is independent of its intensity. Saturation current means that constant current, okay? And that particular saturation current depends only on the intensity, and stopping potential have nothing to do with intensity. Third conclusion, for a given photosensitive material, there exists a certain minimum cutoff frequency of the incident radiation called the threshold frequency, below which no emission of photoelectrons takes place, no matter how intense the incident light is. Above the threshold frequency, the stopping potential, or equivalently the maximum kinetic energy of the emitted photoelectrons, increases linearly with the frequency of the incident radiation, but is independent of its intensity. Fourth, the photoelectric emission is an instantaneous process without any apparent time lag within the time interval of 10⁻⁹ seconds or less, even when the incident radiation is made exceedingly dim. Here, see, with the help of photoelectric current, one can calculate the number of photoelectrons emitted, and with the help of stopping potential, one can calculate the maximum kinetic energy with which electrons are emitted. See, all the electrons emitted from the emitter are not emitted with the same energy. When negative potential on the collector is applied, then those electrons which are emitted with very less frequency will be repelled first. As we increase the negative potential, then more and more electrons will be repelled, and at last, at a stopping potential, when the electron which one was emitted with maximum kinetic energy is stopped, then the photoelectric current becomes zero. So at the potential difference V0, the energy given to the electron, that is EV0. So we can say the maximum kinetic energy with which electron is emitted, that is equal to EV0. So we can say this thing here, the stopping potential that depends on the maximum kinetic energy with which electrons are emitted, and that depends only on the frequency. It have nothing to do with intensity of the light, because when the frequency is changed, stopping potential is changed. Means frequency is changed, the kinetic energy of the emitted electrons also changed. So these are the conclusions.